This video will talk you through part 3 of classwork 20, going over the independent samples t-test cosmetic surgery example. So let's start by just reading the example. Cosmetic surgery is on the upswing. In 2014, there were 20 million plastic surgery procedures undertaken around the world. With such popularity, psychologists have become interested in the motivations behind those that go through cosmetic surgery. There are two main reasons cited by most patients. Number one, to help a physical problem, such as having a breast reduction surgery to relieve backache. And two, to change external appearance, such as having a facelift. Here we have a data set collected by researchers who are interested in why people pursue cosmetic surgery. This data set is called cosmetic surgery and is located on Canvas. So here are the variables that are presented in this data set. We have base QOL, which is a measure of quality of life before a 6-month period. Post QOL, or post quality of life, that's their quality of life measured after a 6-month period. Base BDI, which is the Beck Depression Inventory score. That's a very common measurement or common tool or survey that's used to assess people's depression levels. So in this case, depression was measured before the 6-month period started. And low numbers on this inventory, on this BDI, indicate less depression. So lower numbers mean less depression, higher numbers mean higher depression levels. Surgery. So patients at these clinics were randomly assigned to when they would receive their surgery. This variable tells us whether this person has undergone the cosmetic surgery during that 6-month period or whether they're still on the waiting list. The waiting list group in this case is acting as our comparison group or a control group. This group also wanted to have plastic surgery, but they actually went through the procedure after the 6-month research period. So during the 6-month research period, when they did all these measurements, some people had the surgery and they were coded for number 1, or they were still on the waiting list and they had not had the surgery. So they were the control group, and that's group listed as group 0. Clinic just tells us which clinic they went to. There were 10 clinics that they could have attended to have their surgery. We can also see their age, the reason that they provided for having surgery, whether it was to change their appearance, 0, or for a physical reason, 1. And we also can see their gender. Females are coded as 0 and males are coded as 1. So consider this distribution of depression scores. Okay, so here we have a histogram showing depression scores. Depression scores are along the bottom, so we can see from 0 up to over 60. And here we have the number of people with that particular depression score in that range. So we can see there's kind of this bimodal looking shape here. So what are some variables that might explain why we see this variability and how depressed individuals are? Why do we see all these differences in depression levels? So this is one of those where you could start thinking about maybe these are males and these are females, because females tend to have higher depression levels than males. Maybe it has something to do with their age. Maybe it has something to do with whether they had the surgery or not. Oh, but keep in mind, this is the base level. I'm pretty sure this is the base, let's see, BDI. Yeah. So this is before anybody had surgery. So again, maybe we see sex differences, but what we're actually going to explore here is maybe these differences that we see in depression scores have to do with the reason why they had plastic surgery, okay, or cosmetic surgery. So in this case, we're going to be considering whether their depression scores are related to the reason why they had surgery. Because again, we said maybe this would be male and female. Maybe it's more like appearance and physical, or maybe those two things are swapped around and this is physical and this is appearance, right? But it's interesting that we see there are two pretty distinct bumps here. So we want to know what's going on, and we're going to be looking at how it connects with the reason. So perhaps one question we can ask is the reason for plastic surgery related to depression scores? And I'm going to talk you through this because it's a little confusing. So let's say that yes, right? So going with the alternative, yes, their reason is related to depression scores. So if the reason why they are having cosmetic surgery is related to how depressed they feel, then would we expect the two different reasons to have the same depression score? Right? If we think depression score, if it is connected to why they had surgery, either appearance or physical, if we think that how depressed they are is linked with why they want surgery, then we would expect these two groups, the people who say they're doing it for appearance reasons and the ones who say they did it for physical reasons, we would expect to see different depression scores, right? If the reason is related to how depressed they are, then we should see a difference between the people who said this reason versus that reason. If their depression score has nothing to do with the reason why they had surgery, then we wouldn't expect to see any difference here because it has nothing to do with why, right? So appearance, physical, doesn't matter, about the same. Okay. So in this case, our alternative hypothesis is going to be that reason for plastic surgery or for cosmetic surgery is related to depression scores. Or in other words, we expect to see, or versus saying, that's more like, so we could say that we expect to see depression scores that differ between the people who did it for appearance reasons and those who did it for physical reasons. All right, so we would not expect these two groups to be the same if depression is related to why they're doing it. What is the null hypothesis? Well, the null hypothesis we would expect if, so we would say reason not related to depression. And if the reason is not related to depression, then we would expect the depression scores to be essentially the same between the people in the appearance group and the people in the physical group. Right? So in this case, our null hypothesis is going to be that the mean of the appearance group is the same as the mean of the physical group. There's no difference in the depression scores between those groups because depression is not related to why they want surgery. That's the null hypothesis. The alternative would be the opposite of this, that we expect to see some difference between the means of those two groups. So let's go ahead and fill out our chart here. So we can copy over our null hypothesis from up above, and there are several different ways you can write this. You can write it, I believe in the videos, she tends to prefer the like x minus y, this kind of method. I typically think it's more straightforward to just say this group is going to be, make that clearer, equal to this other group, that the means are equal between our two groups. That's the same thing as this. It's just saying the mean of the difference between, or the mean difference is 0, which is the same as saying the means are the same. Over here, we would say, okay, the alternative, well, the alternative is that the means are not the same. They either are the same or they're not the same. The null is always, nope, nothing interesting happening. They're just equal. The alternative is always the opposite. Now, step 2, we want to identify our alpha level. In this class, we are always using 0.05. For step 3, we want to set up our decision stage. So this is the S-DOD. So this is looking at the difference between the two means, right? Like this mean difference. So let's see here. Our decision stage, note degrees of freedom. I gave you this hint because we're not going to look it up. Critical T for this is 1.97. So I know on a T distribution, that's a 0. That's 1, 2, 3, -1, -2, -3. And so 1.97, well, that's going to be just a little bit short of 2. And then keep in mind, we're always doing two-tailed, so we want to do the same thing on the other side. We got -1 point, right? So this will be our -1.97, and this is our positive 1.97. Those are our critical T values, right? Plus, minus 1.97. So that means this region here and this region here in our tails, these are going to be our rejection regions. So if our sample T that we get falls anywhere between -1.97 and positive 1.97, if it falls in this middle section, then we are going to not reject. But if our sample T is higher than 1.97 or lower than -1.97, then we will reject that null hypothesis. Now, this part on 4, you can find this information in the back here. So we have our T value. We also have a P value. We have the mean difference. So this is the information we're going to need for above. So the mean difference is 25.29. So that mean difference, I'm going to put here 25.29. And that is the mean, that is the difference between our two groups on their depression scores. So when we look at our descriptive statistics, remember this is the appearance group and this is the physical group. We can see 98 people in our sample said they had surgery to change their appearance, and their average depression score, their average BDI, was almost 40, 39.37. We had 178 people who reported having cosmetic surgery for physical reasons, right, to treat some sort of physical pain or discomfort. And their depression scores, on average, were about 14. So we're seeing for appearance, that group's mean is around, be more precise here, around 40. The physical group's mean is around 14. Okay, so this mean difference, this 25.29, that's the difference that we see between our two groups. Right? 39 minus 14, that'll give us our 25. So we've got that written in. Now, what is our sample T and our P? So I'm going to double check. Sample T is 22.59 and our P is less than 0.001. So we'll go ahead and put those in here. So 22.59 was our sample T and our P is less than 0.001. So we can do this step 5 one of two ways, right? So let's do it both ways. The first way is if comparing sample T to critical T. So sample T is outside, right? With the outside versus inside, so greater than critical T. Then we're going to reject. If it's not greater than it, then we do not reject. So our sample T, we've got 22.59 versus our critical T, which I provided up here, 1.97. Hopefully you can see this 22.59 is much, much, much bigger than 1.97. This means if we tried to plot this T value of 22.59 on our graph, this would keep going way out here. We would go 4, 5, 6, 7, 8, 9, and eventually we would get to 22 and 23. And a little more than halfway in there is 22.59. So that 22.59 is extremely far out in our rejection region. So in this case, we would reject the null. Now, the other way of doing this, which I think is a little more straightforward, it's typically what we do in practice, is we compare the p-value versus alpha. So if our p-value is less than our alpha, then we reject the null. If our p-value is not less than alpha, then we do not reject. So let's take a look. What was our p-value in this case? Our p-value right here, p equals, well, actually it's less than points. This means that p is so small, it's almost zero. It's so small, it's got lots and lots of zeros, and so we're just going to say it's so small, it's almost zero, but it's not quite there. Our alpha level, as always, was equal to 0.05. So the question is, which one is bigger, 0.001 or 0.05? So 0 versus 0, same. 0 versus 5, this one's bigger. So this one is bigger because Pac-Man wants to eat the thing that's bigger always. Okay. So we get that our p-value is less than our alpha level, which is this case, reject the null hypothesis, because 0.001 is definitely less than 0.05. So these two decisions should always come out the same. Regardless of which method you use, you should always come out with the same decision. Reject, reject, or do not reject, do not reject. So let's go ahead and wrap this up with writing a sentence indicating what our conclusion would be with regards to our research question. So I would say something along the lines of people who have plastic surgery to change their appearance appearance are significantly, and why do I say significantly? Because I'm rejecting the null. That means it's significant. More depressed. You may be wondering, how do you know they're more depressed? Well, which group had the higher depression value? The appearance group. Since remember, high depression scores mean high depression, low mean low, we can see the appearance group has much higher depression scores on average than the physical reason group. And since we found a significant result because our P is less than 0.05, we can say this value, this group is significantly higher than this value for this group. So significantly more depressed, and then if I were doing this in APA style, which you should be, M, that's just supposed to be a regular M in italics, not a mu. And we would say what the mean for this group, it was 39 point something, 37 or something like that. And we would put the standard deviation. Than who? Than people who have plastic surgery for physical reasons. And again, we would put the mean, the standard deviation, and then we would write out our T portion, which I'm going to have you practice down below. In this case, remember degrees of freedom always go in here. So you're going to put the number for degrees of freedom in there. The T value itself, this T that's reported in your output goes here, comma, and then you put the P value. And in this case, we're just going to write it exactly as JASP has it, less than 0.001. So you can go ahead and practice putting this all together and then doing the write-up. And let's just go ahead and wrap up. I'm going to quickly show you how to run this in JASP so you can see how I got this information. So here's our data set. We have whether they had their surgery or they're on the waiting list, their base quality of life, post quality of life, which clinic, age, depression score, reason, and gender. So we want to go to, in this case, we're running an independent samples t-test. The reason for that is because we're comparing two different groups, right? The group of people who did it to change their appearance versus the group of people who did it for physical reasons. And there's nothing that links any individual person in one group to any individual person in the other group. So they're just two completely independent groups of people. So we're going to run t-tests, an independent samples t-test, because we have two samples that are not linked. We want to move the base BDI, which is our dependent variable. It's the variable that we're interested in. We want to know, does depression differ between these groups? That is our variable of interest. And then between what groups, right? Who are we comparing? What is the other variable that's going to tell us which two groups we're comparing? That's going to be reason, right? So this will give us the two groups, appearance versus physical. And we want to see, is there a difference in this variable between the groups in this variable? Now we're going to leave most of this as is, but let's go ahead and do location parameter and confidence interval so we can get our confidence interval. And we also want to select always for our descriptives so we can see those descriptive statistics and you can see more clearly where they came from. So once I've done that, here we go. We can see here's our T value, degrees of freedom, P value. the mean difference and the confidence interval for that mean difference. Notice 0 is not in here, which matches the fact that it is significant. We would not expect to see 0 in here if it's significant. And we can see the change appearance group, on average, their depression scores were about 40. And for the physical reasons group, their depression scores were about 14. Although the standard deviations aren't that much different, right? They're still spread out around 8 to 9, 8.5 to 10. So hopefully that helps to kind of clarify this example. We are going to be using this same example in the next classwork. And so, which is actually not the next classwork, in classwork 22, when we do our introduction to Anova. So keep this in mind. We will be coming right back to this example.